Okay, evaluate the following limit graphically and numerically. So let's take out our calculator, and we need to type in this function for our calculator. Okay, I have my function up here, x divided by x plus 1, square root of x plus 1 minus 1. Now I'm going to press graph and look at the graph of it here. So we've got our graph, and what point are we concerned with? We want to know what's happening as x approaches 0. So the number that we are concerned with, we're worried about this number right here on the x-axis. What's happening as x approaches 0? So we want to look at the function right around this area. What's happening there? Well, on this graph it may be a little difficult to see. What can we do? We can press zoom. We can press zoom and 2 for zoom in. And see if we get any better indication. So if we take this picture, which is just a blown up version of this, and look right around x equals 0, right in this particular area, it would appear that x is moving in this direction. Looks like we might be getting close to the number 2. If we look from that direction, looks like we might be getting close to the number 2. So if we're looking at this graphically, we say, it looks like we're getting close to the number 2. Would you agree with that? Well, what about looking at it numerically? Let's see what's happening there. So if we press second and table set, and for table start, I'm going to put in 0 because we're concerned about what's happening right around 0. And let's just leave our delta table at 0.01 for a moment, and let's see what happens. So if we look at our table, and at 0 we get an error, which we kind of expect to get that for most of them, because if it's a number, then it's real easy, and we don't have easy problems very often here. But let's look what's happening to the right of 0. Remember, that's this area over here graphically. We're looking, it's 2.05, 2.01, 2.148. But if we look at it going down towards it, the numbers are getting smaller and smaller, and it looks like they might be getting close to 2. Well, let's see what's happening on the other side of it. Remember, these are numbers that are to the left of 0. That's the numbers over here. And they're all less than 2, but they're getting bigger and approaching the number 2. So if we look at this thing graphically up here, or if we look at it numerically down here, I think in either case we can conclude that the limit is 2. So we can determine from this that this particular problem, the solution is the number 2.